This is Professor Pelton. This is Trigonometry, Chapter 2, Section F. This is Part 2 of 3. This is going to cover the tangent and cotangent frame methods. So the frame method for tangent and cotangent are based on the premise that every tangent cotangent looks the same. So essentially every tangent always looks like a pinwheel going up like this. Okay, and at the ends, there are going to be asymptotes, which are labeled with these dotted lines here. Okay, and what we know about tangent is sine over cosine. So if we do sine over cosine, that works fine for the whole values of pi, but when you get to the half values of pi, there's a problem. Because when you do sine over cosine, it's undefined, hence the asymptotes. Okay, so basically every half pi we have an asymptotes. Other than that, the top and bottom values for DNA are the same for sine and cosine as they are tangent cotangent. And essentially makes your pinwheel. It goes up like that. Well, that's a very bad representation. Essentially it will look like that when we're all done. Okay, and the difference for cotangent, if we move it down a little bit here, is that the values go the other way. Okay, and now the problem is at every pi, because at every pi, it's not going to have a problem. Because when you do cotangent, cotangent is cosine over sine. So as a result, these values, cosine over sine, are undefined at every value of pi. So we have to do every value of pi now to figure out the asymptotes. Other than that, the cotangent is the flipped version. Okay, didn't quite do that right. Let's try that again. Okay, let's do some examples now. Okay, so the first one is a tangent. So for each one of these, we need to put in our asymptotes. So the asymptotes are on the end. Okay, all right, let's write out our values here. So A is 3, B is 2, C is negative pi, over 2, and D is negative 1. Still a bad pi. Okay, so first we need our initial and ending starting values. So make our formulas. So we take the inner part of the tangent, 2x plus pi over 2 equals, and 2x plus pi over 2 equals. So the tangent is undefined every half pi. So negative pi over 2 and pi over 2 will give us the beginning and end of the initial cycle normally, but we're going to shift them now. So we'll subtract pi over 2, subtract pi over 2. So gives me 2x equals a half and a half gives me 1. Divide by 2. X is negative pi over 2, and that'll give us our initial value from the first asymptote. And the second one, minus pi over 2, minus pi over 2. So 2x equals 0, or x equals 0. That'll give us our second asymptote. Okay, so we have to add them up and divide by 2. So this one is essentially negative pi over 2 plus 0 divided by 2. Well, half of a half is a fourth, right? So we can erase that. So that'll be a negative pi over 4. Okay, and if we add these two up, 0 plus a fourth, so that's negative pi over 4 plus 0 divided by 2. So a half of a fourth is an eighth. So that's negative pi over 8. Alright, on the next one we have 1/2 and 1/4, so that's really 2/4 and 1/4 over 2, so that's really 3/4. So 3/4 divided by 2 is 3/8. So that's negative 3 pi over 8. Okay, you can prove that to yourself again because the 1/2 and the 1/4 gives me 3/4. If I divide that by 2, that's 1/2 over 1/2. Cancel, cancel, which gives me my 3 pi over 8. Okay? Alright. So we know every pinwheel needs to look the same. So they all have these 3 points to make the pinwheel go up that way and down that way. Now we need to figure out our top and bottom. So that's d plus a and d minus a, absolute value. D is negative 1 in this case, and a in this case is 3. So we get 2 and negative 4. So 2 and negative 4. So if we add 2 plus negative 4 and divide it by 2, that'll give us negative 1 for the last value there. Okay, let's erase that. Alright, so the last thing is the period formula. The period formula is pi over b, because the period of tangent cotangent is pi, not 2 pi. So in this case, that's 2 pi over the 2, where I simply just get a pi. Okay? So the domain, it goes forever left and forever right, which is true. It goes forever left and forever right, so it's all real. Except, if you notice, the asymptotes are every half pi. So every half pi we have a problem, except x cannot equal n pi over 2, where n is an odd integer. And of course up and down it goes forever up and forever down. So that's forever down and forever up. Notice it always goes from least to greatest. Okay, so using this frame, we will make the graph down below. Okay, so noticing the fractions, I have fractions that are halves, eighths, and fourths. Since the 8 is the highest denominator numerically, so we will go with the 8 as to how we label the graph. Okay, so we have 1/8, we have 2/8, we have 3/8, 4/8, 5/8, 6/8, 7/8, and of course 8/8 for 2 pi. We'll go the other way. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. Okay. Alright, so what's important here is the negative pi over 2 is the asymptote this way, and the 0 was the asymptote here. So this is just one cycle of the tangent. Okay, there are obviously multiple cycles here. So at negative 1, at pi over 4, we had the 0. So at the center of the pinwheel. and the pi over 8 negative and 2 is the other one. And the last point was negative 4 and 3 pi over 8. Okay, so that makes our initial pinwheel. It's not very good, but you get the idea. And of course, there'll be another one here, and another one here, and we keep repeating itself left and right. If we wanted to make more of these, we just have to make them every half pi, repeated the same. Okay. All right, let's try the next one. Pause the video, try the student problem. Okay, next one's cotangent. So again, asymptotes on the end. We need to figure out our values. So A is 3/2, B is 1/2, C is negative pi over 3, and D is 1. Okay, so the problem with cotangent is every pi we have a problem. We have an asymptote because it's undefined. So we'll take our inner value, 1/2 x minus pi over 3 equals, and 1/2 x minus pi over 3 equals. So 0 and pi will be the first ones for every iteration of pi. Okay, solve the equation. So pi over 3, pi over 3. So 1/2 x equals pi over 3 times 2. X equals 2 pi over 3. So that is our initial value when the first asymptote is. And we'll add pi over 3 and pi over 3. So 1/2 x. So let's see, 1/3 and 3/3 is 4/3. If I times it by 2, x is 8 pi over 3. Okay, so all we have to do now is add them up and divide by 2. So 2 pi over 3 and 8 pi over 3 is 10 pi over 3. And if I divide that by 2, that's going to give me 5 pi over 3. It's only half of them. Okay, we'll do the next ones. So 2 pi over 3 plus 5 pi over 3 is 7 pi over 3. So if I divide that by 2, that would be a half times a half. So that would give me a sixth. Alright, the next one, 5 pi and 8 pi gives me 13 pi over 3. So 13 pi over 3, if I divide that by 2, that's going to give me sixths again. Okay, now we can figure out our top and bottom, which is the d plus a and the d minus a. So d plus a and d minus a. Alright, so our d here is the 1. And our absolute value of a is 3/2. So as a result, the top value is 5/2, keeping it as fractions, and the bottom one is negative 1/2. So 5/2 plus negative 1/2 divided by 2. That's going to give us a 1, because essentially you're going to get 4 halves or 2 on the top. So 2 divided by 2 is 1. Okay, so our period, the formula for period for cotangent and tangent is pi over b. But in this case, b is 1/2. So if I times it by 2 and 2, that cancels, leaves me with a 2 pi. Which makes sense here. The distance from 2 pi over 3 to 8 pi over 3 is a distance of 2 pi. Because if you subtract 8 pi over 3 minus 2 pi over 3, that's 6 pi over 3, which is 2 pi. So the distance is 2 pi. So up and down, this goes this way for all versions of cotangent. Right? And essentially it goes down forever and up forever. Okay. The domain here is in terms of thirds. We're going to skip that for this time. It's a little complicated. We can come back to it later, though. Okay, let's use this to number our graph. Noticing we have thirds and sixths, therefore we need to use sixths in our graphing for the axes. Okay, so we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6. What did I say? 8/6. That'd be 9/6 next, right? 3 pi over 2. 10/6. 11/6. 12/6 is 2 pi. 13/6. 14/6. 15/6. 16/6. That's 8 pi over 3. And 17 pi over 6 for 17/6 and 18/6 for 3 pi. Okay, so we know that 2 pi over 3 was the first asymptote. And we know what 8 pi over 3 was the other asymptote. Okay, and we know what 1 and 5 pi over 3 gives us the first one. 5 pi over 3 and 1 gives us the center of the pinwheel. The left-hand side goes up to 7 pi over 6 and 3. And the right hand of the pinwheel was 13 pi over 6. And I'm sorry, that wasn't 3. It was 5 halves, wasn't it? So that's right there. Excuse me. We're off by 1. And it's negative 1/2 below. And that's at 13 pi over 6. So 13 pi over 6 and negative 1/2. That gives us our initial cycle of cotangent. Okay. That is the end of part 2.